Welcome back. Now this is the first workshop, so actually now it's your turn to start analyzing data. As I mentioned before, the only way to learn analyzing data, or in fact anything in life, is to try it yourself. You have to try it. You have to get your hands dirty, play with data, struggle a little bit, and then start learning from it. Now you will find all the material in GitHub as before, all the data sets, all the solutions. So I strongly recommend you try it first yourself. And once you have tried yourself, you can go into the solutions and you check out the video and you see how things can be done. Alright, let's get started. So our focus here in workshop 1 is to analyze data, focusing on what we called descriptive statistics. So we explore the data set, we don't yet move into some more advanced methods like regression analysis. We will do this in the next session. All the instructions you find on the slides, which are on GitHub. So the only thing I have done now is I took all these instructions and copy-pasted them as comments into a Stata do file. Let me just close the PowerPoint, move into Stata. I opened up a session and I also opened up a do file. In fact, I have it here, so that's my handout. So here I copied all the instructions. The only thing I already added is I added the change directory, so my path into my working directory. I opened the dataset using the use command, the name of the dataset, and then using the clear option to clear any data in memory. I just run this for a sec, and let me also zoom a bit so that it gets easier to see. So here we are, and now we open the dataset. Okay, so the first thing we have to do is, based on our instructions, we have to locate the variable B228, and we have to rename it because it doesn't sound really good. It's actually a variable that captures personal pensions. Alright, so we do that first. Again, I stress, try this yourself. Pause the video, try it, and then watch it and see what happens, and you try the next one. Yeah, so just do a little bit at a time and see whether you're able to do it. Now the first part is quite easy. So we might use the look for function, and we go into pensions. So we go into the descriptions and look for pensions. And the first thing we find is indeed this B228 variable. Yeah, and this is personal pension. I don't want to go into the details what personal pensions are, so that's a UK specific term. So these are basically pensions where you contribute personally and not your employer. And there are certain tax benefits. Yeah, so I'm a professor of finance. I know quite a bit about taxes, and most importantly how to optimize so that you don't pay too much of tax. Okay. Let's do that first. I go into the do file, and I don't want to work in the command line. I just want to do it here because then I can replicate. I use rename. We have done this before. B228, and then I rename it into pension if I type it properly. So that should rename it. Yeah. So that's fine. So we now have our pension variable. The next step is also quite easy. It's the same principle. We have to look for income. We already have seen this before in the previous unit. So I just copy paste that and rename it into income. Then we do our first descriptive statistics using the tabstat command. We have seen this before in the session on how to get tables out of Stata. So what we want to display the mean, the median, and the standard deviation. Yeah, and we want to have these ideally in columns. Again, we might need to check out how to do this. So if you're unsure about this, I always recommend going back to Stata and simply asking. So you go into the help function, you go to Stata commands. If you know the command, you type in the command like tabstat, and you get now the syntax. You see the first thing you have is you have a var list, so this is a list of variables. So that's straightforward, and then you have various options that are introduced using a comma. We have statistics here, and you see the part underlined is the necessary part. You just have to type in S, and Stata would know what you mean. In brackets you would refer to the name of the statistic, and here are all the statistics that you might use. SD is for standard deviation. Of course, if you work with Stata for many years, like in my case more than 20 years, you know all of that already. Yeah, but of course if you're new to it, it's easy to find and easy to start understanding the syntax. Okay, let's get going. Let's do tab stat. Let's put in the pension and the income. Let's use the option for the statistics, and here we do the mean, median and standard deviation. And then we want to have in the columns the statistics, so we have to specify columns, and then in here we say statistics. Okay, so that should do it. I run all of it, and let's see what happens. And we have now a nice table. Of course we can optimize the table, and we can also export tables into Word and also into other formats. The easiest thing to do is simply to do a right click on the table and say copy table as HTML, and then you can go copy paste into Excel, and you can modify it as you want by hand. So that works quite fine, honestly. If you want something a bit more sophisticated, I did one video on exporting tables using commands in Stata, and there are certain benefits to that. Good, but now we have a nice table. We have our mean, we have a median, we have a standard deviation, so that's all working fine. Good. Now the next step is a little bit more complicated. Let me see what we need to do. We have to define a dummy variable. Now dummies, we have seen this before. Dummies are indicators, so it's a 1 if something is the case, and a 0 if something is not the case, so depending on what you want to measure. So we want to basically label working age households, so we want to label them with 1 if all the members are below the age of 60. And there's a hint, we might need to combine various conditions using logic, using an AND logic. Okay, good. So whenever you generate a new variable, you have to use the generate or Aegean command, depending on what you want to do. Now we need to look at what variables we have to measure age. So we go back into the data and do a little look for, and we look for age, and there are plenty of them. And in particular we need age for older people, so this category here, and you see that the number of older people, so 60 above, is captured in these 3 variables. Yeah, so if anyone in your household is in one of these, you would not be classified as working age. Again, of course, it's a very specific definition here, not necessarily the best one, but we just take that as our starting point. So we want to make sure that the working age households, they do not have anyone in these 3 categories. Yeah, so that's what we try to code. Okay, let's move back into the do file. Use the generate command, and let's call this working age as instructed, and in here we assign a 1 if a certain condition applies, and the condition is if now this variable, which is the A045 variable, is equal to 0, so nobody is above the age of 60 and up to the age of 65, and the A046 variable is equal to 0, which means that nobody is between 65 and 70, and then you go above that. I think it's 70, might be 75. Let's go back in here. It's 70, and then you go above 70, and then we have A047 equal to 0. Yeah, so what we have done is we specified here an if condition, so that's basically branching. We have a first condition, and we connect the next one using the AND logic. Yeah, so that's the syntax. It looks different compared to other programming languages. Yeah, so if you're used to Python, that's a bit different. Yeah. Good, so that's it. Yeah, again, of course, see the difference between assigning values and equal to statement. Again, this is very similar in other languages. Yeah, so that should not be a major issue. So now, once you run this, what it does is it basically assigns the one if this condition is met. It doesn't know what to do if a condition is not met, so it will actually generate now missing values. As we have seen before, these missing values are coded as dots in Stata language. So what we need to do next is, again, you can do this differently. You can use a replace command, which we have seen before. So we replace working age with what? You have to ask with equal to 0 if working age is equal to missing. So equal to dot. So that should generate now my dummy variable. Yeah, so if I run this one more time, I should hopefully succeed. So now we have our working age defined. We could just quickly have a look. So you do a simple summarize command. We go to the bottom here where this is created, and we just have a look how it looks like. Let me just do that. And of course now, if you look at the mean of this, it would mean that 60% in your sample would qualify. So about 60% of the households in your sample have nobody in this age category. Yeah. Again, of course, it's a certain definition we use. It's not a perfect definition to know whether someone is working or not. That's not the purpose here. The purpose is only to practice these if statements and to practice the use of logic. Okay, so that looks all promising. So we have done that. We should be fine. Okay, so good. So now, how many households in working age do not have any savings for pension? Now here, to be precise, it refers to the personal pension we defined before. And can you confirm that more than 80% of households in working age do not contribute to a personal pension plan? Good, so how to do this? There are many ways you could exploit now your knowledge of Stata to answer that. The first thing you can do is you can go into a summarize command. Yeah, you can just do something like this. You do a summarize command and you go into pension. So you want to know what happens to pension. If in this case working age is equal to 1, so that will basically look at all of it, at everything. So it looks at all the households where you have actually information about pension, because sometimes it might be simply missing. That are classified as working age households using our definition, which is not maybe the best definition. So that would basically, if you run this, you should get now information about pensions, whether any amount. It could be also 0, as you can see here, for all the households that would in theory be working age. Yeah? And of course, among this selected group where you have actually pension information, you can then investigate further. Because what you see here, if you compare this observation number here and that one, it means that for quite a few cases, more than 2,000, you don't have any information about personal pension. Yeah, not even that it's equal to 0, it might be just missing. So by running this command, you ensure that all the missings are kicked out. Yeah, so basically here you ask, do we know anything about personal pension for households that qualify as working age? And the answer is we know something in 3,171 cases. Okay, so that's good to know. Now the next thing you can do is you can then do another summarize command and simply use the AND logic and simply ask, now how many are there that have no pension whatsoever? So what we do here is we just simply ask whether pension equal to 0 is fulfilled. Yes, if you run this, you now know how many cases are there. So you see there are 2,726 cases. Yeah. So what you can then do is you just do a little display. So this is basically like a calculator, and you look at these cases divided by the cases where you have information. And it means that about 86% of the known cases, they don't have any personal pension. So households that are of working age, based on the definition of nobody above the age of 60 is a member of a household. Out of this group, 86% have no personal pension. Of course, we have also lots of people where we don't know anything. We have to also stress that. Yeah. So that's interesting. So we can confirm, yeah, more than 80% do not contribute to a personal pension. Of course, they have other forms of pension. Okay, so that's quite interesting. Now, apart from this, you can do other things which are similar. Yeah, so there's another thing which I show you, which does actually the same in terms of information, because actually what we only want is observation. So you can do, instead of summarize, you can do count. You can try this. That also works. It simply counts the number of observations. If you run that, it gives you oops, Warn is not allowed. Okay. Of course not. Because you don't need, you just count whether the condition is met. That's all. You don't need, because we don't need any statistics. So basically, just count the number of cases where we have working age people, and then we count the number of cases where we have the information that pension is equal to 0. Yeah, so that's all we do. Let's throw this in. And here we are. Yeah, so that's useful. Okay, that's good. So it does the same basically. Now again, you could do the display if you want. Yeah, you can also assign this to a different variable if you want. So that's another way of looking into this. Just counting observations. It would also exactly achieve what you wanted to achieve. Again, there are other ways of working on this. You could now really assign the count to a variable. So that's another thing you can do. And that can be done using the Aegean command. So we could basically take this first line and modify that as follows. We can say, okay, Aegean, so we generate a count variable. I call this count underscore all. And this count underscore all is simply counting. It's a count function, and I pass in what I want to count. I want to count actually information regarding pension. So that's in here. Or I can actually also do this on working age. It doesn't really matter. And if working age is equal to 1, so that's exactly the first condition. And then I can do another count variable. Where I say, I think I just could say here, no pension. Let's do this. No pension. Again, I refer to counting. I count pension. I can also count something else because I just want to look at observations. I don't want to look at anything else under certain conditions. And now I throw in the second condition here. So the only difference between these two lines, 6061 compared to 5657, is that I assign this count value to a particular variable. That's the difference. Yeah, and it might be useful if you want to, work with it, and use it in any other calculations. So, for instance, what you can do now is you can now generate a new variable, no saver. So people that don't have pension would be equal then to count no pension. So that's your count variable, divided by your total count. Yeah, so you could assign it, you could then work with this, and then if you want to see it, you can just throw in a summarize command here. Yeah, so no savers. So we can try this and see what happens. if I didn't do any typo. Let's just run this and move over to Stata. So here we are. So well, it does exactly what it's supposed to do. So now again you get the same ratio, so about 0.86%. The only difference now is that we have now, you see that below we have now some variables which we generated. So if you do a BR, a browse command, we can just look at these variables. So there are variables actually existing in our database. Yeah, so it exists in our database now. So sometimes that might be interesting if you want to use it for any further calculation, for instance, but it's just a different way to do this. It wouldn't be my preferred way because I don't want to create variables I don't necessarily need, but it might be useful if you want to use it for any further modeling. Good. The last bit is now to define a new set of cases where we have more than 3 children in a working age household. So now the conditions get a little bit more complicated. And then I want to do a box plot on the pensions, and I want to see whether there's a difference depending on the number of children. Well, I think most likely the answer is there will be a difference. But let's have a look at children, and again we have to go back to our age structure. So if we go back to look for, and we look at age, that should be enough. I just break that here, and we have to now look for the age of people. I think here number of children, here we are. So these are younger children. Yeah, so here for instance, here we are. So these are children in the age bracket 5 and under 18. So it depends, of course, now exactly how we want to define it. It's up to you. Yeah, I'm not an expert on how many children should be counted how. So for instance, you could count all the children or just a specific age range. In terms of costs, quite often, to be honest, the costs tend to be higher in a certain age range. So what I now do is I just pick out this one here, which is for age range 5 and under 18, assuming that they might be quite costly. Again, of course, you can in the comment disagree on that. I'm only a stats guy, so I'm not into the social stuff too much. Yeah, it's all about data. So I just take that now as a definition. Cool. I just threw it in here, so that's my variable. I will use it in a minute. So I generate another dummy variable, which I would call more child. More child is fun. I assign value 1 to it if a certain condition is met. So if there are more, now I use that, more than 3 children of the age category 5 up to 18. Again, you can of course modify this. You can combine them into one category, and that's absolutely fine. If you want to see that, just leave a comment below. And again, I refer to my working age household definition. So this is working age household definition. So I just use the same condition as before, and then I replace my more child dummy equal to 0 if the more child dummy is missing. Yeah, something like that. So that should do it. I don't think there will be many cases. Yeah, so that I wouldn't expect. Yeah, so we can have a little look now. So if you now do a summarize command and you go into more child, you have a look at how many cases we are talking about. So the mean is very, very low. So it's less than 1%. Yeah, it's 0.6% of cases. If you combine this now with an if command, you can actually count the cases. Again, you can of course use count. So if we do something like this, and then we just put in more child equal to 1, you see we only have 32 cases. So that's a very, very small number. Now, of course, statistically speaking, if you now want to visualize that, you will find it much more of a struggle because there are not really many cases. Yeah, so that's an issue. So if you now do the box plot as demanded, which we have seen before, so it's graph box on pension, and now I use as a variable here by, so over which I want to make a difference, and this is the more child dummy. So if I do this, and I just run the whole thing one more time, and you see now that the output, of course, is simply driven by the fact that you don't have many cases, so you don't see an awful lot. And also the other issue is that many people don't contribute at all into pension. So there are many people that basically have 0 in pension, and so this is of course also what you see in the box plot. You can just have another look at pension. So if you go just to pension for all households and put in a detail as an option, you see that a large proportion of the population doesn't make any contributions, and then very few make substantial contributions. So that makes a big difference. So in terms of visualization, then you have to think about how to really visualize that. So for instance, you could start visualizing it by simply kicking out the cases where there is no single pension contribution whatsoever. You just focus on the ones that actually make at least some contribution. So again, this is something you have to think about in terms of your own problems and how you structure your analysis. Good. So I hope that was enjoyable, and again I stress it's important for you just to try it yourself, and after that have a look at the video, have a look at the solution, and of course I stress there are many different ways of doing it. So please feel free to explore the data based on your own research questions, and if there's any issue, just leave a comment below. That would be much appreciated. Thank you very much, and I see you